left already that I'm starting the class. I'm starting the class. They can join. All right. I think you have a group, right? WhatsApp group.
Yes, sir.
Yeah. So send a message there. Those who have not joined but previously joined and can come. It will be a very short class, of course. So you have sequence of numbers and coming from, let's say, real numbers, and then corresponding to it, you have studied whether in
Sir,
yes.
part of the board is cut out.
Oh, blur out. Is it so? Everybody, it's just blurred out.
No, sir, it's cut out means the camera isn't capturing that part. It needs to be moved, I guess. Adjusted.
I can see here. Is this fine? Is this fine?
Yes, sir. Now it's fine.
All right. Okay, so we have taken whether this, we have studied whether AN converges or diverges. Excuse me. হ্যালো, হ্যাঁ আমি একটু পরে যাচ্ছি, ভুলে গেছিলাম একটা ক্লাস আছে আমার। ঠিক আছে, ওকে, হ্যাঁ বলে দাও, আমি 3টে পরে যাব। ওকে। Yeah, so whether AN converges or diverges. So what does it mean? So can anybody tell me what converges means and what diverges means? Yes, let's make it interactive. So please tell me.
Sir, to A and B converged, there for every epsilon greater than 0, there should exist some n belongs to natural numbers, such that for all small n greater than capital N, an minus some point a is less than epsilon.
Right. So convergence, what does it mean? You have some point existence of the point A, and if you take whatever small neighborhood you can choose, whatever small neighborhood you choose, you get, except finitely many points, all the points lying in the neighborhood. Right? That's what you said. So neighborhood is, this gives you the epsilon. So given any epsilon, there exists n. N means after finitely many numbers n, all the n's lies in this neighborhood. Right? So this sequence is very important. You already know, right? So you have learned in school the limit, right? Limit extends to a something holds. But what is limit? It's actually limit extends to a. What does it mean? It means that there exists a sequence xn that goes to A, or there exists for all sequence xn that goes to A, you have some properties. Yeah. Anyway, so and what does it mean to say a sequence diverges?
If a sequence does not converge, it diverges.
Oh, it's sequence that does not converge. What does it mean? Right?
That means even after infinite points, it is not approximate to some points.
Right. Still not clear. What does it mean?
Means
Divergence
there
means
exists.
Yes.
there does not exist such an n such that there exists no n such that all n after that n, I mean for all indexes after that n, the value of the sequence will come in a small interval around any point.
Right. This is negation. This is the negation. But I want,
Negation of the
yeah.
definition of convergence.
So I want you to understand what does it mean? What it means by the negation.
There are two types of divergence.
What?
One divergence which we say diverges to infinity. It basically means that the function, I mean, after some point will continue increasing, go on and on increasing. That is divergent to plus infinity, and go on and on decreasing is divergent to minus infinity, which are similar. And another is oscillatory divergence, which basically means that the function oscillates surrounding some point, but doesn't come close to it.
Yeah. Right? We have sequence.
I didn't get the question.
Yeah, there is no function here. So you have sequence, right? So what is oscillatory divergence?
Like -1 to the power n. This oscillates but does not.
So that is basically the point. So look at one example as -1 to the power n. Second example as, let's say, n. All right. Third example as -1 to the power n, n. Right? All the sequence diverges. All right. So in this case, what you get is there are two limit points and 2 points where some of the, I mean, most of the members of the sequence actually goes there. Right? So there are some numbers around which most of the member lies. Actually, all the members are kind of either 1 or -1, right? Here, the same tends to infinity, increases to infinity. Here, sometimes people say it converges to infinity. Right, so provided you have the notion of infinity properly defined, and notion of converges to infinity also properly defined. Here, this is again some part which is actually looks like -n, and there are some parts which looks like n, and this decreases to -infinity, and this increases to infinity. All right. So the point is, of course, one is the limit point can be. So the point is, in the extended set of real numbers. Suppose this is minus infinity, this is infinity, and this is the extended system of real number. You get either one of the endpoints, or at least 2 points where a subsequence goes there, right? So that's actually divergence, right? Either the endpoints, either one of the endpoints, or there exist 2 points where you can get some part of the sequence goes there and some part of the sequence goes there. Let's say this is called A and this is B. There exist at least 2 numbers where some part of AN, which is a subsequence of AN, goes there, and a part of AN goes there also. 2 distinct numbers. So if this happens, there exists at least 2 such, then you say it's then of course it is divergence. And this is the negation gives also this one. This case is either it goes here or there exists 2 numbers. This here or it might happen like this, 4 number 4 minus 1. This case goes to minus infinity. Right, so this is known thing. We didn't go to sequence of functions yet. So now, if you look at, for example, sequence of functions. So let's look at example 1, fx equal to x to the power n. X belongs to 0, right? Now you combine a lot of sequences together, right? For every x in 0, 1, you are getting a sequence. So fn, this is it. Right? For example, you look at half here. So look at fn of half. This is a sequence, right? Similarly, suppose you put x naught here. So fn x naught is a sequence. So is the board visible now?
Yes, sir.
All right. Yeah. So
No, sir, it's very hazy.
it's with easy. Okay. Yeah. So we are looking at the sequence of functions. Fn is
Now
fn,
it's become clear.
okay. So fnx equal to x to the power n. I don't know, even the net connection, LAN connection, it is with the desktop computer, with the LAN connection, still it is being heavy hazy. I don't know what is going on. Yeah, maybe it is because of camera as well, maybe. I don't know. Okay, so look at this fnx equal to x to the power n. Right? So I'm speaking the same thing, what I wrote there. Now, at every point, for example, if you look at a point half in 0, 1, so fn half. So corresponding to fn half, what is the sequence? This one is 1 over 2 to the power n, right? And this one is 1 over, x naught to the power n, right? So does it converge? Fn of half?
Yeah.
Right? It converges to 0.
Yeah.
Alright, so this converges to 0. What about this?
May or may not.
May or may not?
Converge.
Yeah?
Sir, if x naught is 1, then it will not converge to 0.
Yeah, x naught is any member.
Yeah,
X
if
naught
x naught is 1, then I mean x naught is any number between 0 and 1, 0, 1 included, right?
Yeah, yeah.
So if x naught is 1, then fnx will not converge to 0. It will converge to 1. But if
But
it's anything else, then,
this converges.
yeah, converges, but not to 0.
Converges. Converges. Let's since I put in the inside. So suppose this x naught not equal to 1, then it converges to 0, right? And I want to put fn at 1 separately, which is nothing but the sequence 1 to the power n, right? And this converges to 1. This is 1, right? So So, if you define a function fx 0 x belongs to 0 to 1 open and 1 when x equal to 1. Right? If you define such a function, then you see that then you see that fn x naught converges to f of x naught, right? For all x naught means 0, 1. Is it clear? This converges. Is this clear?
Yes, sir.
Right? So this is sequence of number. This is sequence of number. It converges to a number. But these numbers together gives you a function. Right? So fix a point, look at a sequence of number. So this is the scheme. Fix a point. X naught. Look at the sequence of numbers, real numbers. Fn x naught right. So this two and see whether it converges. See whether it converges. Right. So this is one scheme of convergence or one notion of convergence. for a sequence of functions. So you are given a sequence of functions on an interval. Okay. What you want to do is fix a point on that interval. So given, maybe mention, let me mention this one. So given a sequence of functions fn on, let's say, interval AB, you fix a point first on AB and look at the sequence fnx naught and see whether it converges. It's sequence of real numbers now, and you know the convergence, divergence, everything, right? So this is one scheme of convergence. So in this case, this fn converges to f, this fn converges to f. So this scheme of convergence is called pointwise convergence. So this notion of convergence is called pointwise convergence. All right, is this clear? I have not defined it formally, but look at the essence of it. Is this clear? If you have any question here, please.
Hello, sir.
Yes.
Fn x is equals to x to the power n, right?
Yeah, that was the example. Yes.
Okay.
So you didn't see, could not see, is it?
No, I was just confused.
Okay. Yeah. So that was the example. So in this case, that was example. Here, in this case, fnx is x to the power n. That was an example. So this was part of example, but this is the scheme. Given a sequence of function, look at a point on that interval, look at the sequence of real numbers, and look at whether it converges or not. All right. Yeah. Any other question?
Sir,
Yes.
uh,
Are you
is
sure?
it pointwise convergence a property of function or the interval?
Yes, you are looking at C. If you are fixing a point x naught, but what you are looking at a sequence, right? Sequence of real number
Yes.
coming from the functions. So it is a property of function on an interval, on its domain.
Okay, sir.
If the functions are not defined, then you cannot say anything, right?
Yes. Yes.
So function has to be defined on that point. All the functions has to be defined. And then you can talk about the convergence, whether this convergence, the numbers f and x naught converges or diverges, right?
Yes, sir.
As you have done for case of real numbers.
Thank you, sir.
Okay. Yeah. Any other question? Yeah. So let us make another example. So can you give another example of pointers convergence sequence?
So x by n.
X by n. All right. So example 2. Fn x equal to x by n on, let's say, an interval a. Subset of R. Right. So this is a sequence of functions. All right. Now where does that converges?
0.
Right. It converges 0. Right. So you fix a point. So fix x naught in AB. And now look at the sequence Fn x naught, which is x naught by n, right? This is a set of real number. For example, a by n at the point A. So if n of a at the point a by n. So where does this sequence go? 1 over n goes to 0, right?
Yes, sir.
So 1 over n goes to 0. So if you put any number m, capital M by n, this sequence also goes to 0. All right? Yeah? This sequence is real number. Right. Is it confusing? This 1 over n, this goes to 0, right? As n tends to infinity. Alright? I think everybody can do it, prove this in epsilon delta form, right? Epsilon n form. Right? This is the first sequence of the numbers you must have encountered after the constant sequence. So if you put capital N, n is moving, n is fixed, n fixed. This also converges to 0 as n tends to infinity. Is it correct statement?
Yes. Yes, sir.
Okay. Yeah, so this is a correct statement. So that is what we are using here, right? So that is what, using that, we can see that this converges to 0 as n tends to infinity. And this is true for all x naught in AB. All right. All right. So what is that limit limit of this Fn is, so this Fn converges to 0 pointwise on AB. Alright, is this clear to everybody? Is this clear?
Yes, sir.
Yes, sir.
So let's look at another example. So can you give another example? Let's look at a, yeah, so we have not defined it, but yeah, let's look at another example of pointwise convergence sequence. Can you give another example?
So x plus x square by n,
X plus
x square by n.
let me write it here. There are a few examples. Somebody has wrote, right? So whoever wrote in chat box, please speak. I'll write that example also.
X by n plus 1.
X what? X by
Nx plus 1.
X by nx plus 1. Right? So this is fnx equal to, this is also fnx equal to x by nx plus 1. So you need, so when you give a sequence of functions, you need to give a domain
Sir,
of, yes.
sir, if fn x equals to x to the power 2n can it be converged?
X to the power 2n, yeah, right. So let me write this one also. Fnx x to the power 2n. So you need to give a domain. So your domain is here.
The all real numbers.
On, if you look at on R, then there is a problem. Problem in x to the power n also. Right?
The last one will be 0, 1.
Yeah. So maybe you put, so if if x is bigger than 1, then this x to the power n does not converge. So let's look at on 0 to 1.
Sir,
Yes.
for last example, if we take fx equal for the last example, if we take fx equals to the last example, if fnx equals to x to the power 2n.
Mhm.
For this, if we take fx equals to 0 for x belongs to -1 to 1, fx equals to 1 for x equals to +1 and -1, and fx equals to infinite for rest, then fnx will converge to fx.
Oh no, you considered when the function converges to I mean it goes to infinity, you say it diverges, right? That is the notion. So you cannot say that, right? So the point is a sequence of numbers n, for example, n, does it converge?
No.
Right? So we by what? Yeah, actually, this is an assumption, or rather, what should I say? This is assertion that when it goes to infinity, one would not say it converges, rather it say it diverges. So that you cannot say. And taking infinity does not give a function. Right? A functional value from R to R does not take value infinity. Right?
Yeah, okay. Got
Yeah.
it.
So that point is, so you can take this one as from -1 to 1. That is possible. All right. So you need to give a domain. So what would be the domain of this one?
Sir, real numbers minus 0.
R,
Real numbers minus.
0, because 0 on 0 it won't converge, I think.
No, this example 4, right? So
on 0 it is 0.
at 0 it is 0.
So
All
it
that
can be
is-
R.
Right.
Oh, okay. Yeah. Sorry. Yeah, at 0 it is.
So maybe you look at on 0, 1. There will be problem only when x is -1 over n. Right?
Yes, sir.
Yeah. So on 0, 1 you are fine. And here also let's look at on where. Here on
R.
real number you can take. Right? So a lot of examples we have. Actually, you get the examples. Right? So now let us look at whether these things converges or not. What about the first one? Does it converge? So it is already 3. Can I extend it few minutes or I need to stop? If you have another class here now, then I have to stop. Or if you are, some people are very hungry, then I have to stop. So what do you want?
It's fine, sir. You can. We don't. Nobody has a problem.
Okay, so maybe, so I'll take 5 more minutes to see where these things converges and then we leave. Because I think people started leaving already. Yeah, so why does this converges? This is, of course, you see x is independent of n. So only this part you need to look at, right? And x squared by n. So this x squared by n converges to 0 as n tends to infinity, right? So for each fixed x on R, this holds, right? This is similar to what we said, this m by n. Instead of m, you now have m squared. All right. So this converges to 0. So this actually x plus x squared by n converges to x as n tends to infinity. This is, I am looking at only as a sequence of real numbers only, right? I have not still defined formally what is pointwise convergence is. What is pointwise convergence? I will define it next class, and you will do all these things through that definition also. That will be an exercise to do. Of course, these are similar things, same thing. All right, so here this Fn converges to F pointwise, where Fx is equal to x. All right. So what about example 4? This converges to
0.
yeah, converges to 0. Yeah, converges to 0, right? So at 0 it is 0. And take any other points. X naught, n x naught goes to n x naught plus 1 goes to infinity as n tends to infinity. All right? All right?
Yes, sir.
So x naught by n x naught plus 1 goes to 0. So this goes to 0 as n tends to infinity. And of course, what about here?
If x is not 1 or -1, then it converges to 0, and if x is 1 or -1, it converges to 1.
Right. So if fn converges to f pointwise, where f is where f x is 1 0, x belongs to -1 to 1 option, and 1 when x is -1 and +1. All right. And is this fine? So at least these examples. So what you need to do is to look at more examples. Right? So today, tomorrow, look at more examples. So the sequence of real numbers, from there you construct sequence of functions. You yourself construct without looking at the board. Okay? And construct and see whether this converges pointwise or not. Okay, so do you think this one is sometimes? Working in the board is also good. Yeah. Apart from what I plan to do using iPad.
Yeah, sir, it's fine.
Yeah, okay. So today I forgot basically to bring that. I didn't know. I didn't actually remember there is a class. I thought that class is tomorrow. Yeah, all right. So we'll meet on, I think on Friday, right? Friday at 11.
Yes.
All right. Okay then. See you on Friday. I'm sorry for the delay today. All right. Bye.